downloaded a file, please make sure you create a folder in your local drive, H drive, because we're going to use it, and copy it in there. So for instance, I've just copied the file in there. And the reason it's important and actually put all of the files in one single folder, because once you operate, it will create the new files for you, including these kind of codes that they're all linked to each other. So it's exactly like an assembly. You have different files that are linked with each other. So make sure actually you copy everything and put it in the one file, in one folder, sorry. Great. So let's go back to this presentation that Dinah went through it in the previous session. And I want to just ask you a quick question. So the 3D printing, is it which of these manufacturing methods? You already have the solution in front of you, but I want to see it actually. What's your point of view about it? Is it additive or subtractive? Yes, please.
Additive.
Additive, great. And do you know what's the reason we call it additive? So what's the reason?
Material to get to the desired result.
Exactly, yeah, well done. So the majority of the methods of the manufacturing, they're subtractive manufacturing methods, because we are removing the materials from them. Whereas 3D printing, the new methods of manufacturing, they are additive, as you mentioned, because we're adding materials to it. So what you're gonna learn through the CAM side of the module, we're gonna work on the subtractive manufacturing methods, and we're gonna learn how we would be able to use the CAM software to help us to operate the subtractive manufacturing machines such as CNC. CNC is one of the best manufacturing machines, and the reason for that is a high accuracy. If you remember the video that Diana showed, the accuracy you would be able to get from the CNC machine, they are brilliant. Even they're smaller than the the size of the hair, which are great. But in order to communicate with these CNC machines, you need to know a language in order to communicate with that. Last year we had EG4010 modules. Do you remember what was the name of that language which we use to operate the CNC machine? What's the CNC code? What's the name of that language? Do you remember? Any one of you? What's the name of that language we use?
Oh, was it G codes?
G code. Well done. Well done. Yeah, G codes and G codes, and M codes, but it's basically they call it the G code is the way that actually we communicate with the CNC machines. And if you remember from last year, writing the G code is not something simple. So you should start with the number of lines, N1, N2, whatever. A G function, G1, G2, for instance, G1 is the line, G2 and G3, they're arc, clockwise and anti-clockwise arcs, and a location of every single point you are moving to, an X, a Y, and a Z, and also you have the M and T for tooling, and also the feed rate, that sort of that. So I'm gonna quickly show it to you how a G code looks like. For instance, by the end of 3 tutorials that we do, you will get something like that. And you can see for a simple part, how many lines of the code do you have? Do you see that? And you have to, or you had to create these line of codes by yourself, which is really complicated and it's really time consuming. I just want to quickly say, for instance, let's say here, once I start programming, I use the G40, I'm gonna use the tooling compensation, and then I wanna put it into the XY plane. So I wanna say to the machine that actually you need to operate in the XY plane, use the absolute programming, and also you have the multiple cycles. And then for that's for instance, one of the lines. I will say, use the rapid move, and then that's the, the absolute programming again, goes to that point for the X, that point for the Y, and also I put the M as well, which which is another set of things that actually we have to explain. So it's really time consuming and it's really complicated. So that's why the software developers, the software engineers, the same way they come up with the idea of the CAD, because CAD could help us to save time and could help us to visualize what we are doing better, they come up with the CAM part of it as well. So not only you would be able to generate the code that you will be able to upload it to the CNC machines directly through the software, you would be able to visualize it as well, so you can see what's going on. The CAM these days is quite well known. Having it in skills in your CV were brilliant, because lots of companies, they no longer have these facilities in-house. So what they do, they use the outsourced services all over the board, and you don't need to actually be there, or you don't need a special technician to work with you, because with the CAM, you know what's going on, you can visualize it, and you just complete the code, check it whether everything is fine, and then send it directly to them, and you're sure that everything will be fine because you already simulated. And this is why we are using the CAM. NX is one of those brilliant software that have the CAM module included into the software. So you're using the same sort of software from the time you start with the CAD, you would be able to continue with the CAM as well. So in order to use the CAM, you need to have access to the CAD geometry. You need to have a CAD file. So that's why in NX it is straightforward for you, because you already have the CAD. You will use the CAM to be able to get that G code, which usually is a .nc file you will get, and then you upload it to the machine to operate. So in order to do that, and you can see here, so you will have the machining setup, which I will explain to you shortly. Then you do the operation programming, and also you would be able to get the code at the end. So let's start from the CAD file. The file that you downloaded, it's .par format. It's a solid edge file. And if I go to NX, if I go to open, let me go to the where I save my file. I won't be able to see it here. And the reason, because it's a solid edge file. So usually I receive this question from the student, how they should open the file. It's really simple. So once you go there, make sure you change the file type from .prt, which is the default format of the NX, change it to the all files. So you would be able to see this file and click OK, and wait for the software to open it and convert it to the NX compatible format. So let's wait for it. So up to the time it actually is trying to open the file and convert it, make sure you go to the file, open, and change the format from .prt to all formats and any file. So you would be able to locate the file and open it into the NX. It might take some time because it's trying to open it and also convert it at the same time. I would recommend you to please do it at the same time with me. So please, once you downloaded the file, put it into the folder, and then try to locate it through the NX, open it, and wait for it to actually open the file and convert it to the .prt file that it is compatible with the NX. Good. So once the file has been opened, then you go to the file and save the file, or you can use Control S. Of course, you can go up and save it. And if I go to the folder, you can see now I have another file which is created for me, and it says it's a Siemens part file. So if I go to the properties, you can see that's the .prt file. I'm not sure whether it's show it to me or not. Yeah, that's a .prt file, Siemens part file. So I converted it to the NX format. So that's the first step you need to do. Okay. So once you open the files, you can see that you've opened the file in here. And now you have to start by choosing the setup. So I'm gonna come back to where I open the file and I save it as a .prt. You can see it here. I need to take it, now we are into the modeling environment. I need to take it to the manufacturing environment. There are two ways of doing it. If you remember from the way that actually we were dealing with the assembly, you had the option that technically you will come up with the one single file that has the different stages into it. So you could have the, for instance, the CAD part that has the drafting attached to it, or as a separate file. Depends whether you are the designer of the part or you're a different department. Usually for the CAM, you're coming from different department. You're not the same person who designed it. So if you want to use the same file, you would be able to go to the application and click on manufacturing, or you can use the Control Alt and M together. But as I said, usually you are coming from different department in charge of the CAM. So that's why even for this tutorial, I will recommend you to do, you go to the file and create a new file. So you can either go to the file and new, or you can use the Control and N, which will come to here. In here, you can see you are into the modeling environment, which you have access to create a model, assembly, these sort of things. For manufacturing, you have to move from the model to the manufacturing, and you will see the different templates in the manufacturing. So if you know what kind of operation you're gonna do, it's better to use that template. For instance, if you wanna do the milling and hole making, you will choose this one. But what I recommend you to do, if you go to general setup, you can see it has all the templates for the machining that you're gonna do. It have the turning, all these kind of, machining, the milling, hole making, everything all together. For this special part, because you can see you're gonna do these kind of two pockets there. So you will use the milling there, and also in order to make the drilling hole, for instance, the first one is fine. But let's go to the general setup. You can see actually how the software gonna change its environment to make it suitable for you. Then you will be able to open the file. Because we already opened the file, it would be automatically come here. If not, what you need to do, you need to click here and open the file. But I would recommend to open the file first, so it would automatically come here. And also here is where you need to save it. Make sure you save it in the folder that you have the CAD geometry into it. Otherwise, whenever you change the location of the CAD geometry, every single time you get the error that please link it back again. And of course, you would be able to name it as well. So I'm gonna just continue everything with default, and I will click OK. So as you can see here, the environment now has been changed. So that's the machining environment. So please go and open the part into the machining environment. And let's continue it together. Thank you. And please type in your question or switch on your mic and ask if you have a question. Okay, so once you open it into the machining environment, you would be able to see that in here, you have the NC program, the program you're working on, and there's a name here, 1, 2, 3, 4. That's the name of the program, which you will be able to change it and rename. So in here, I'm gonna change the name of it to whatever you're looking for, but this tutorial asks to change it to the plate machining. I'm gonna just copy and paste it here. So what I will do, I will just go there, click on 1, 2, 3, full name, right click on it, and go to rename, and paste it here. Or you can type it, whatever you're looking for. It's the same things, and enter. A quick question. Do you know what's the reason you use the underscore on the line here? Any idea? Yes, please. What was it? I didn't hear that.
Is it so it doesn't confuse it with a minus?
Oh, it's one of the persons actually respond, spaces are not allowed, and let's try it. And do you know what's the reason spaces are not allowed in here? It's related to what you learned last year in the EG 4010. Let me change it for you. So I will rename it with a space, and you can see the space is not allowed here. As a hint, what we're gonna do, we're gonna generate the G code at the end, right? And if you remember, in the G code, you are not allowed to use the spaces because it doesn't understand the space. Whenever you use the space, it thinks now you're going to another function. So if you, let's see this code again that we're gonna generate, you can see every space means that you're going to the different part. Don't confuse the machine, because at the end you're gonna get something like that, and it needs to give access to the file. Any underscore needs to be converted, but any space needs to convert it back to the underscore. So it's equivalent to the spacing. Great. So make sure you rename it to whatever you're looking for. And now what I'm gonna tell you in here, you can see that you're in the operation navigation program. So first here is the assembly navigation. We don't have any assemble, so it's just a normal file. Otherwise, you could see the assembly here. Here is the constraint. We don't be able to see the constraint because we had the file in the solid and it's been converted. Otherwise, you could see the constraint here. Here is a part navigator. You would be able to have access to the parts. And here is the operation navigation. So the operation navigator is where then actually the machining would be able to see it. In here next to the menu, you have the program order view, which you will be able to see your program, the CNC code you're gonna see. So whatever we're gonna do, it comes underneath in here. Next to it is the machining tool view, where you would be able to create the tools for it. And next to that is the geometry view, the geometry that you're having. And also the machining methods that you're using. Some of these, they're appeared here, and the reason for that, because if you remember, I used the general, so it automatically brings these things for me. Otherwise, it's empty. It doesn't matter. We are still gonna tell you how we can bring this kind of operation in here. The same things for there. You will see the carrier and pockets automatic software done it for me. That's why I ask you to open the general template. Otherwise, you have to create these, and I will tell you how you will be able to do. For every CAM, or for every computer-aided machining, the processes that you need to take, these are the things that you need to remember. Opening the file, choosing the appropriate setup, and then you define the geometry, you create the tools, and you do the operation. And at the end, you would be able to get the file that you're looking for. And doesn't matter what file you have, is every CAM process is the same things. And we're gonna do it today. We already opened the file, we already opened the CAD geometry, and we started with the programming. We will name it to whatever you're looking for. You can still keep it as a 1, 2, 3, 4, but you will see that for every operation you create, it wants to link it to a program. So it's better to name it with something that's familiar for you so you can easily distinguish which one you're referring to. And now you want to define the geometry. So in order to define the geometry, I need to move from the program order view to the geometry view. And you can see the machining coordination system here. If I click next to it, you can see there is a workpiece. So again, I will gonna go back to last year EG 4010. Hopefully you remember it. Do you remember that we had something that I've mentioned at whenever you deal with a CNC machine, one of the early stages you have to define into the machine is the coordination system. Do you know what's the reason for that? Do you have any idea about it? Why is it really important to define a coordination system for the machine? Any idea? Or any guess? Great, Jeff said that. Anybody else you want to say? Ebubek, do you want to say something? So yes, please, if you want to say something, yeah, just. This is really kind of, friendly, informal way that actually we're gonna teach. So don't worry about it. Whenever you want, switch on your mark and ask your question or respond to the question. I really appreciate it. Exactly as Jeff mentioned. So whenever you design a part and you've done it into the first semester, you have your own coordination system. It's a workpiece coordination system that you have. The workpiece coordination system is for the part, and because the CNC machine, again, it has its geometry, it still has its own coordination system that it wants to operate. So whenever I want to operate from any of these locations, I will need to define the start for the machines and fix it as a 0, 0, 0, as a x0, y0, and z0. So therefore, I need to come to the geometry and click on edit and specify the machine coordination system. You can either move them around and put it whenever you want to operate, or of course you can put the numbers here. What I know, because I'm gonna put it in that corner, where I need to send it is 130, 130. So it goes exactly to the corner, and Z, I'm gonna keep it at 0 because I don't want to have any distance with the part. And I'll click OK. Then what I need to do, I need to define the safe clearance distance. Again, any idea what's this one? What's this clearance distance? Either from last year or from what the Dyna told you? It's for the tools or it's for the machine as well. Exactly. Well done. So you want the, because whenever you put the tool to the machine, let's say the length of the tool is 10 millimeter. And because I fixed it here, I have to tell the machine always from the tip of the tool, you need to have some distance from the part. Otherwise, for any kind of non-cutting move, it's important, not cutting, non-cutting move, it should keep that distance. You can go as close as possible to the part, but it's not safe. So if you remember from last year, the one who had the chance to operate the CNC machines, we increased the clearance for the part, so make sure actually you don't cut the part by mistake. So we just change it to the 10, and I will click OK. Great. So what I've done, I will just do it recap. Once the programming is here, rename it. You go to the geometry, in the machining coordination system, you edit it and put where you want to operate. In my case, I'm going to put it in the corner. So X is 100, Y is, X is 130, Y is 130, Z is 0, and I put a clearance of 10 and click OK. So if you follow these 5, you can see the same thing. This goes to the geometry view, machine coordination systems, and put it into the corner 130, 130, and 0, and put a safe clearance and click OK. So can I ask you to please do that? Okay. So once you've done it, then I have to tell the machine, okay, I've done the first part. I've done that actually I told the machine where it needs to start, but I have to tell the machine where it needs to operate. So I have to tell the machine what's the workpiece. You can see it automatically created the workpiece for me under the machining coordination system for the milling, which, as I said, you need to click on plus to be able to see it. So what I will do, I click on that, do a right click, and click on edit. You can see these things, they're off. And the software, they're trying to help me. It says specify the part. So what I will do, I'll click here to specify the geometry that I want to use. And click OK. As simple as that. If I had more files, more part, I would be able to choose more files that I want to operate. If it was the full assembly, I want to just use a section of that. Otherwise, for this one is bad. And if I want to check it, once I have something defined, I can display it. We're going to use this one a lot to make sure actually everything is fine to the next stages. So whenever you don't see any kind of display next to it, it means it's not defined. So I specify the part. Now I need to specify the blank. Do you remember what was the blank? What is the blank that I need to specify? Any guess? So I know where to operate, I know where to start, but I don't know something. What's that?
Is it the thickness of the material? So like how far the machine bit has to go?
Yes, it's contributed to that one, but technically, whenever you have the part, thank you so much, Charlie, for the answering the question. Jeff, the question was, what's the next stage? I specified the part. What's the blank that I need to define? Elbeck, do you want to add something? Yes, what was it? I couldn't hear you properly. So what we are trying to do, you don't, whenever you put the part into the machine, it's not like that. That's the end goal, right? So you need to put the raw material, and because you're using the subtractive method, you're gonna remove this. So what you're gonna do, you're gonna put the block of material, a block of raw material that you're gonna remove these pockets and the holes. That's why you need to specify the blank. Whatever the length of this one you're aiming to reach, you need to have something higher than that to remove the material from it. So based on what you're thinking you're gonna do, based on what operation you're aiming to do, you need to define the blank. So let's say I'm gonna put it as a cylinder, for instance, here. Am I looking for something like that? No, I'm looking for something rectangular, a bounding block. And if I want to operate whenever I want to operate, where do I want to operate? For this tutorial, I'm gonna remove some material from the top because I want to have a really clean look on the top. So I'm gonna use a face milling on that. And I want to remove 5mm material from it. So I will add ZM5. Do you see that? 5 material will be added to my bounding block. So that's the raw material. What I will do, I will remove these 5mm to have a really clean top. The best example, if you have the MacBook or the Surface laptops, you can see they have a really clean lid, which made by aluminium, the aluminium, and they've used the face milling to reach that really good level. So the same sort of things. If they wanted to do, I don't know, on the Y, you could add it into the Y as well. So you can see if you want to do operation on the sides. You don't have any operation in this one, so just keep it 0. I want to operate on the Z. And let's make it, I don't know, 50 to see what I mean. So if I do 50, then I have to do the operation. It takes longer for me to operate, and it's more expensive because I'm wasting the part. I'm wasting the raw material, right? Because I have to do these, removing these material to reach to that. Finding this number depends on what method you're gonna use and how you want to operate, how clean looking you're looking for, which again contribute to the final price of the manufacturing, and your product would be more expensive. So in this case, we're gonna go for the 5mm, and I click OK, and you can see if I go there, you can see I have a 5mm bounding block. Then I have to define the material for the machine. Do you know why it's important to define the material? Usually in the CNC machining, if you put the parts there, once you fix it, that second question they would ask you, what's the material?
Is it so that because different tools have different applied to different materials?
Yes, exactly. So different materials have different properties. So different tooling that I'm looking for, they have the different properties as well. Let's say if this one,
speed rating.
Exactly, speed as well. Brilliant, fantastic. It contributes to a lot of things. First of all, I can understand how much pressure the machine is required to put on the file, on the part that I have in order to remove the material. Let's say if this one is aluminium, then I can say, okay, at least I can use the metal to be able to remove the material from it. But if I'm using the same sort of, two steel at the same sort of grade, I'm damaging the part and also the tool that usually they're expensive as well together. And if I don't apply properly, even you can damage the main actuator of the CNC machine as well, which usually they are starting from 100,000 pounds to a few million pounds, and they are quite expensive as well. So I can understand, first of all, how much pressure is required from the machine to be able to remove the material, why it doesn't damage the part, and also, as Charlie mentioned, it will impact the time as well, the time of the operation, the time of the cutting as well, which everything going to contribute to that one. So in here is a carbon and steel, and I think if I remember correctly from the tutorial, we need to change it to aluminum in here, or whatever you're looking for. This is just the tutorial. Well, let's change it to the aluminum. So it's really important to just define it as well and click OK. So another recap, I keep coming back to this because it's really important to know the stages. Name the programming, you go to the geometry, make sure you define the coordination system for it to define where you want to start. Put the safe clearance distance. Once you do that, you go to the workpiece, make sure the part is specified, and make sure you have enough blank, a raw material to be able to use, and also make sure you define the material. So if the part you got doesn't have the material, you need to define it for the first time. If you already have the material, make sure it's the correct material that you're gonna use and click OK. And if you go to here, we'll tell you this. So this is where I define the blank, and also where I change it to the aluminum, what I wanted to do. So please take your time to do these stages before I actually go to the next stage. And also ask your question if you have any question, please. Thank you. Now, what I want to do, I want to start doing the operation. So in order to start doing the operation, the first thing I have to tell the machine is, any idea what's the next stage, what it should be? Exactly. What type of the tool that actually we want to use? Well done. So whenever you're dealing with the CAM, you have to think about, because what the CNC is trying to do is trying to replace the human resources to be able to do it. For instance, if you want to do 1,000, I don't know, 1,000 holes, or do a milling in the surface to remove the material, you have to do it a million of times. Depends how many parts that you have. Let's say if each part has 4 holes and you have 1,000 parts, so you have to do it 4,000 times. So CNC is trying to make it automated for you and make it easier, of course, cheaper and faster. So let's say you're gonna operate on here. So if you want to do it by hand, so you have to first then take the part, look at it to see where you want to start. This is what you've done. You've defined the coordination system. Then you want to see how much pressure you want to do, for instance, if you want to do these drillings on the drill. Then what you need to do, you need to put the correct drilling size into the drill to be able to do it. So you have to define the tool. And then once you do that, then you start doing that drill, for instance. I'm going to go do to another one. So there is the route you take, or we call it a path you take. So this is the path operation. The same sort of thing. So whenever you're dealing with the software, think about it, how, if you wanted to do it by hand, how you would be able to do it. So as your friend Jeff mentioned, we're going to define the tool. But which of these tools do you want is suitable to be able to remove that bulk of material? If you remember, here, I create that blank. So I'm going to remove that 5mm. What sort of tool I would be able to use to remove that bulk of material? Any idea? Great. Face milling. Face milling is brilliant. Yeah, correct. Exactly. So you're going to do the face milling, which is part of the milling family, to be able to remove the material from the surface. So what I need to do, I need to go to here, to machining tool view, to be able to see the tools. If you don't use any kind of, generic machining or general template, you don't have these carrier, you don't have these pockets. So the carrier pockets, there are the kind of, groups and categories that help you to make sure every single operation, every single step will be attached to one specific operation. So if you're doing, for instance, with this ball, you need to have a carrier. Because I use the template, it automatically has it for me. If you don't have that one, I'm going to show you to you how you would be able to do that. So in order to do this one, what you do, you click here to create a tool. Make sure you are into the home. If you're in any other page, you don't see that. So while you're in the home, create the tool. And make sure you click on the carrier. Put it whatever name you want. I'm going to put it 1, 2, 3, 4. And OK. And you can see it's created here. But in your case, because you already have the template, it's automatically created for you. And that's why I recommend you to do, because it's just a saving time and the software do it for you. So that's the first thing. I will do it one more time. So in order to start, you need to go to the create tool. Make sure you move on from, make sure you're in mill panel first. Make sure you move from here to here, a carrier. Name it for whatever you're looking for. Click OK and click OK, and then automatically create it for you in here. And if you want to delete it, you can always right click in here and delete. So that's the first thing. And if I go here, you can see that's the first things it asks you to do. Create tier, tool, make it carrier, and make it where you want to do. So that's the first. Then I have to tell the machine where you want to operate a group of them, where you want to actually put them into the groups that you want to operate. For instance, in this part, I might say I want to have a pocket. I want to consider that one as a pocket to operate. And once I'm doing this one, I'm going to operate this one. I'm going to have the whole design as a full pocket because I want to do a face milling on that. And also each of these are going to consider as the big holes as one pocket. So you have these holes, and also the smaller hole as a different pocket. So I'll put them into the group. So once the machine is doing it, put it different sequences. So for instance, in here, first I'll do a face milling on the top. Then I'll do operation on these two. So it would be one pocket on the top, two pocket, these big holes, third pocket, and also these smaller holes, fourth pocket. So these are grouping. So if I want to create a pocket, what I will do, I'll go to the create tools, make sure I'm into the mill planet type, change it to the pocket, and also put it into the carrier group that you're looking for. Let's put it into the carrier 1, 2, 3, 4, and click OK. And pocketing number, I'm gonna start with the 1. I click OK. You can see actually, I'll put it into the here. You could rename it whatever you're looking for to do, and you can always come back here and name it for what you're looking for. Again, because I've already used the template, you can see it think that 30 pockets required and automatically created those for me. So that's why I was recommending you to use the a template, a general template. So you don't need to do that. So do it one more time. You go to the create tool, make sure you're into the pocket, you put it into the carrier you're looking for to put it, name it whatever you're looking for. Let me put that one as the test, for instance. Click OK, OK, and you can see it's come here. And if I want to move this one around, I can pick it up and bring it outside. If I want to put it into the different carrier, is exactly like working with the computer. I can put it in here. And if I don't want it, I can right click and delete it. To be honest, I don't need these things that I created, so I'm gonna delete them because the software automatically done the carrier for me and automatically create the pockets which they are empty and I can use it. So for instance, in your case, you can try that one, but because you already have these, I'm gonna move on. I'm gonna wait for the first operation to do. So as your friend mentioned, as Jeff and Charlie mentioned, we're gonna use the face milling. So in order to do the operation, I have to tell the machine what tool is required. So what I will do, I'll go to the create tool, and I will make sure I'm into the milling first. And then I have to think about whether I want to have my special tooling or whether I'm gonna use the standardized tool. There's a pros and cons for that. Usually, the big companies, the big manufacturers, they try to use their own kind of customized tool. Do you know what's the reason for it? Any idea what's the reason that, for instance, Apple or Mercedes, BMW, they use their own special tooling?
So other companies can't work on their products. So if a repair needs to be done or for a part to be made, it has to come from them.
Fantastic, great. So what you're trying to do, you are trying to make sure that the third parties or gray market wouldn't be able to copy your design. So you want to increase the complexity of doing that kind of duplication, or to make a replica of your model. That's one of the major benefits of doing it. And also, even whenever you want to even do a maintenance on it, if you use the special screwing, for instance, they have to even buy or acquire these materials from you, which are usually, they have to pay for it, which are expensive. And of course, if they want to copy it, again, they have to go to the production of it, which usually wouldn't be a mass production, so it would be more expensive for them to do. The other hand, to be honest, it also give you much more freedom as a designer to do. Let's say, if you want to make that hole, which you don't have any special drilling for it, technically you have to change or optimize your design to the way that you have a special tooling for it, so you don't need to create a special tool to be able to use that. But otherwise, if the company tells you you're happy to do whatever you want to do and we are making that tool for you, this is another sort of thing, so giving the flexibility to the designer. In this case, I want to use the standard part. Because it's a standard, I don't create a new tool. I have to still come to the create tool, and you can see I went to the create tool and open it up, but now I'm gonna retrieve it from the library. So I'm gonna retrieve it from the library. And I go with the milling, and I'll pick the face milling indexable. Any idea why it's indexable? I remember that actually one of you mentioned in the Dyna's session why it's indexable and what's the difference between indexable and non-indexable. Any idea why we call these two indexable? As a hint, I can bring this one. Why do you think we call the face milling in this case indexable? And what's the difference between indexable and non-indexable? Any idea? Can you hear me?
Don't
Yes,
know.
Charlie.
Does it have something to do with the fact that it can move across a face instead of just going like down in a hole?
The reason we call it indexable is because we have the option to change the tip of the tool. So into the face milling, I can change the material of it. Let's say I can want to use a diamond to have a really precise one. Of course, I increase the price of the tool that I'm doing. So the indexable, you would be able to change the tip of the tools. So you would be able to have a really cleaner look of the cutting. That's why into the groups you have the indexable and non-indexable ones. So that's the difference we are using. In here, we're gonna use the indexable. That's why you can see these yellow one, I would be able to change them. And I would be able to define them as a flute length. Do you see that? I would be able to define it. In my case, I don't want to do, I want to go with the exact one which is available for me. So we'll click OK and see what the software tells me to do. It tells me what I have, and these are standard, you can buy it from the market, is a face mill 100 mil, the face mill 64 mil. Because I have a large space I want to do, I'm gonna go with the face mill 100 mil, which is enough for me to operate, and I think it's enough for me to do the face milling on that with a short period of time, because of course, once you have the large D in here, then you reduce the amount of time to operate. However, you have to find the best one, because otherwise you might have a kind of big width of the tool that is not suitable for your design, and also you're putting much more pressure on it, which I think next week I will go through it to tell you why you want to operate these two. But in this case, because I have the largest space, I'm gonna go with the face mill 100 mil, and I click OK. And I would be able to click OK. And you can see that tools comes in, and I will be able to change these. I don't want to change it because I want to go with a standard one. So I'll just click cancel. And you can see into the first pocket, it brought face mill 100 millimeter for me. So I'm gonna do it one more time. So as you can see here, I've already created the tools. I've already created the carrier in here. I've already created the pockets. And now what I want to do, I want to create the face milling indexable, and I'll use this one, UGT 0212, which is 100 millimeter face milling. So we'll do it one more time for you. Let me get rid of that. So make sure you are into the operation navigator. From the operation navigator, you go to the machining tool, you open up the carrier, and you see that you have your pockets here. So now you want to create a tool. You create the tool by clicking onto the create tool section into the menu bar. Make sure you're in mill planner. Make sure you have a sub type of the milling, and you don't create the new one. You want to retrieve it from library. So you just click here, go to the milling, and choose face milling. Click OK. It asks you to put the information because you want to retrieve everything. I just keep it clear and click OK. So it gives me the 4 ones that's available to use for face milling. I'm gonna pick the one that's suitable to my design. In my case, it's 100 millimeter, and I'll click OK. Then I will click one more time on the OK, and it gives me the information of that one, which I would be able to change every single of these toolings and holders, everything. But in this step, for this part of tutorial, I'm gonna go with the default. Next session, I will go through the customized one as well. But for today, I'm gonna do everything by default so I don't change it. And I click OK, and you can see the mill has been created for me in here. If you want to do something to notice, because I click OK here, it went with the 30 millimeter. If you want with the default one, like the one that I created on the top, make sure you click on cancel to the last stage. Otherwise, you have it. If you want, you can remove it. So just do it quickly for you. Here, retrieve, milling, face milling, OK. Make sure it comes here. I keep it as the empty, 100 millimeter, OK. And in here, I don't click on OK, and I click on cancel. So it automatically brings this one for me. And I would be able to put it into the different pockets. Do you see that? It created 2 tools because I've done it twice. If I don't want it, I can go there and delete. Or if I wanted even to move it to the different pockets, I can drag it and put it into the different pockets. Let's put it in the pocket 3. As easy as that. If you don't want it, click delete, because this one is enough for me. I'm gonna do a face milling 100 millimeter. I have one tool for it. It's in a pocket mill. And it would be able to visualize it for me. Good. So I'm gonna give you some time to bring this tool, and then we'll go how would be able to use this tool to operate on the top, please. Please raise your hand and ask a question if you have any. Thank you. And what you want to do, you want to, first of all, you can rename the program if you wish to whatever you're looking for. You don't have to. You go to the geometry, because you already, to the operation, you already defined the tool. So you have the geometry, you have the tool, and now the only thing which is remaining is just doing the operation. So we'll click on the create operation. Based on what operation I'm thinking for, because I want to remove the material from the top, I think it's a face milling. So what I will do, I will make sure I'm in the mill planner. And from here, I will look for the one that has the face milling with the boundaries. And you can see the photo tells you what you want to do. You want to do operation on the top. This one, for instance, if you want to have the wall. So probably next week, we're going to do this one if you want to do the internal pockets. But for today, it's the face milling with the boundaries, and it tells you and when you will use this one, for instance. So I use this one, and it tells me what program should I assign it to. And that's why I ask you to make sure name the program based on what is familiar to you. In my case, I'm going to use and apply it to the plate milling, so it attach it automatically to that one. Do I need a tool? Of course I need a tool. What tool it is? I'm going to use the one that I retrieved. If you don't retrieve it here, you have to come here and browse it. Or if you have created another tool, if you've done it 3-4 times, you might have 3-4 different tools here. Because I only created once, so I have only this tool, and I will click. Then what geometry I want to apply is the workpiece. That's where I want to apply, and what method. So for face milling, you have different one. You have the mill semi-finish, mill roughing, and mill finish. Depends on how clean looking you're aiming to do. Let's say if you have a really clean and precise finish you want to have, it's better to do a semi-finish and a finish. So you will have 2 different operations. If you have plenty of materials on the top, if rather than that 5 mil, it was 50 mil, I have to do the roughing. So roughing, do it as fast as possible. It's like a drafting, as fast as possible, remove the material with a really low quality. Then I have to come back and apply the semi-finish, make it a little bit nicer, and go with a finish with a good and precise one. In my case, it's only 5 mil, so even a single operation that will be fine for me, and I will just do that, and I will click OK, and I will come to this page. So these things you will learn it by experience, how many times you have to do it. All these things, I will come back to it later. It contributes amount of the time. Let's say if this one takes 2 minutes, if I had 3 different operations, it would be 6 minutes. And the way that you're paying it to the manufacturers, or even if you're owning the manufacturing department, you're paying based on how many minutes you're using that machine. Let's say if this part, it takes 10 minutes and you have 10,000 files, 10,000 parts to produce every, I don't know, every week, this is how much you pay. So that's a lot of money. And this is the aim of this module for you, how you would be able to optimize it. So you have to define how you would be able to reduce the number of operation, how you would be able to reduce the duration and time of each operation. Okay, now I'm into the face milling. I know I have my geometry, which is workpiece. I have to specify the part. It automatically done it for me because I already defined the part. And now I have to tell the machine when I want to operate. We call it the face boundaries. So I have to tell the machine where I want to cut. It doesn't know. It knows that actually I have the part, but it doesn't know where it wants to cut it. So I have to tell the machine where is the face boundaries. So what I will do, I will come here, click on the specify face boundaries. Make sure I'm into the face, not curve, not points, into the face, because I'm doing the operation on the face, and I'll pick the face on the top and click OK. As you can see here, I know that's the part, and I know that's the face boundaries. That's the face boundaries that I'm operating. So then what you need to do, you need to define what kind of tool path or what kind of machining path you're gonna use. And we use these differently for different purposes. Zigzag, it's, as you can see here, is a cut in 2 different directions. So it goes this direction, goes, come back, do this one, goes and come back again. So it's a 2-way direction of cutting. It's faster, of course. It's a little bit cleaner, but you're removing materials in some areas double than the amount you're looking for. And I will explain it when I show it to you. So I will go with a zigzag. A zig, it takes longer for you to do, but one of the cons of that is that the good example Dina used, for instance, in her session was when you're actually doing the grass cutting into the matches, for instance, the soccer match or football match. You can see that you see some kind of line which comes from it because it's the one cut direction. But the benefit of it, if you do it precisely, you might have a better looking at the end because you're not removing the material double. And also you have the zig with contour. You will do that later, depends on what you're doing in the modeling. If you are doing the, for instance, you wanna do a cutting, which you're gonna get near to the ball, you do the follow periphery, for instance. It's, if you want to, I don't know why it doesn't take me to the next page. Let me close it and open it one more time. You will have the different methods of doing it. Yeah, you can do the follow parts, for instance, depend, or you can go with the profile. So these are the different methods you will be able to use. For today, we're gonna use the zig. So what I will do, I make sure that I have the geometry, it's automatically selected. I have specified my part, I specify where to want to operate, which was that face on the top. And it's a milling finish because I want to do just one operation and it's just finish. And I will make sure it's a zig. And I would be able to define the step over. So I'm gonna go with the percentage of the tool flat. You will be able to change it later. And Dinah, for the next session, we'll go through it, and also next tutorial we'll practice what's the difference between of these step overs to do. And also, yeah, we're gonna go everything with the default, so I don't want to change everything. And I would be able to generate it. So we'll click on generate. If you click on generate, if you haven't defined these on the top, it will show you an error. It will tell you there's a problem and you have to come back to it. So I can see it how I would be able to operate here. Let me show it now. So I will do it one more time. You can see that that's the yellow, that's the blue one is cutting. Go up, non-cutting move, that's that 10 millimeter. Do you remember the set clearance that we defined? And go about do a cutting, non-cutting, cutting, and non-cutting. And if you want to see it, I would be able to click on verify, which is visualizing it for me. Let's change the speed and let's visualize it. And you can see it's telling me how I would be able to do. So it's now is doing a cut. Once it's done the cutting, it would increase it as speed, goes up, and the one is doing it, the one, if you remember, now is doing the G0. It's trying to go as fast as possible to the other point to continue. So that's a non-cutting move. So in order to make sure it doesn't cut anything, so that clearance that we defined at the beginning goes up based on that and do the operation. That's the normal replay. If you want to see how it's removing the material, you can change it to the 3D dynamics. And if I do it like that, it tells me how the material is removed. And I can, of course, decrease the speed to be able to see it. And this is how it does the operation. If you're fine with everything, you click OK, and you click OK. So if you click OK, you can see that you create a carrier, you have the pocket, you have the tool, and now there is an operation attached to it, which is the face milling. And you would be able, if you come to the operation navigator into the geometry section, you can see under the Workpiece, you have the operation, and also that's the tool, that's the geometry, and that's the method. So I'm gonna do it one more time for you. Make sure you click on the create operation. From the mill planner, make sure you go to the face milling with boundaries, put the program that you want to operate, plate milling in this case, the tool that you're looking to do, for me is the face milling, the geometry, it's Workpiece in this case, and it's a mill finish for this part of tutorial. If you have any other ones, you might go with the semi-finishing roughing and then applying the finish. And then if you click OK, you would be able to see that you have the geometry is fine, you have the part, you need to apply the boundaries, the face boundary, which are gonna pick this one, click OK. The cutting pattern, I'm gonna change it to the zig. A step over, I will make sure it's a tool flat. I don't change anything else now. And I will click on generate. And if you want to visualize it, you verify it. And you would be able to see how it's trying to remove the material for you. Of course, if you increase the speed, decrease the speed, it would be the cleaner looking for you, that it will tell you what to do. And you click OK, and you click OK, and that's the second one I created. If you don't need it, you can come here and delete it. If you want to take it to the other ones, you won't be able to do it because there is no tool attached to it. But I can take this one to any other operation because there's a tool attached to that. So if you don't need it, just delete it. So please take your time to do that one, which is important because you're getting closer to finish this part of the process and then get the code out of it. So I'm gonna stop the recording. Please take your time. And so now we've done the operation, but we went completely with the default one. We haven't defined anything yet. Something that's important, even from last year, probably you remember, is called the feeds and speed. What does it mean? It means that every single time, let's say if you want to do for instance, the drilling, every single time you drill, there are different things you need to consider. How fast the spindle would spin, how fast the tool needs to rotate, and how fast you need to go between the different points, the different holes. And this is something that you intentionally, you're doing it whenever you do it, for instance, drilling on the wall or something like that. So in here, we just decided to go with the default. But if I want to optimize my operation, I have to think about the aim you are looking for. You're looking to do it as fast as possible. So you save money because you're paying based on how much minute you're spending on that CNC machine. You are looking to save money, but also you need to consider you want to have a clean looking, and you need to deal with the kind of, the level of cleanness that you have. That is really important to see how your device looks like. If you're looking, for instance, for something which is really important part, let's say into the car, a piston, you need to have a really precise method of manufacturing. So make sure the piston works properly. And that the precision would increase based on how fast the car gonna go for. So you need to have a more precise manufacturing, let's say for a super sport Lamborghini or Ferrari car. If you have a cheaper car, so then it's a different thing. So that quality is not that important for you. And let's say if it's a car console, the quality, although is important, but it's not vital for the car. So the amount of precision that you're dealing with is not that high. So again, so the kind of, how clean you're looking or how precise you're looking to actually your part to be, these sort of things is important to calculate it, to consider how much material you want to remove and how you would be able to do that. So in order to control these, in order to optimize your system and to do it in a way that the system would be able to continue and reach to the way you want your part to be manufactured, one of the things you would be able to change is the feeds and the speed. So basically how tools would be able to rotate to the operation and how fast it needs to move between different points while doing the cutting and while doing the move without any cut. One of them is a surface speed. In here, it's part of this tutorial, I ask you to put it as a 500. And also the feet per tooth, each of the teeth of that tool, how much material it would be able to rotate, depends on how feet you're giving it. What's the speed of that? As a 0.08 as an example. Then I would be able to calculate the spindle speed automatically, and I'm gonna show it to you. So in order to edit this one, go to the face milling. Make sure, first of all, you are in the operation navigation. And also in here, you are into the machining tool view. And in the machining tool view, you open the first pocket. You see the tool, you see the operation you've done. Right click on that and click edit. You will come back to here. So in here you see a section, it says, sorry, feeds and speeds. Please click on that. And you would be able to define the surface speed. In my case, it's 500. And feed per tooth, it was 0.08 if I remember correctly. Yes. And then you have the calculate feed and speed based on this value. Click on that, and you can see it automatically calculated my spindle speed based on these two parameters that I gave. And you will find out how much cut would be for the feed rate. These are automatic. And click OK. And then, because you are doing it, you're modifying it, you have to regenerate it again. So click on generate and click on OK. So please do this one. Then I will go back by doing a little bit optimization and see what's the difference about what I'm doing it here. So I'm going to give you some time so you'll be able to go through it, and then I will repeat it one more time for you. Great. So one of the things that is important, as I said, into the CAM process is you're aiming to optimize it. So you will do it faster and you will do it. So the fasting process, if you do it faster, as fast as possible, you pay less to the manufacturer to manufacture for you. So the timing is really important when you deal with the design engineering. So if you remember here, we use the zig process. And let's say how much does it take to do that process? Please go to the program order view and drag this one, and you will see that process, the plate milling, takes 4 minutes 31 seconds. And the face milling only, because if you have the different process, which we'll do later, the next weeks, for this one, I only have one process. If I go over it, it says 4 minutes 5 seconds cutting, but I have 14 seconds non-cutting. Because zig is a one-directional cut. As you can see, it's a one-directional cut. Do a cut, go up, do a non-cut, and do a cut. So I'm wasting that time. 4 seconds, the one that I have here, the 14 seconds, it's negligible. It's something that you don't care about. But if you have for these parts, it's a simple part. If you have a complex part, you have 10, 20 of these operations. Every sort of them, if it takes 10 seconds longer for that operation, if you are doing the various parts, if you are doing, let's say, 1,000 parts, then you're wasting a lot of time on that, right? So you're aiming to find the optimized method of doing it. So what I will be able to do, this is just an example, which you can even follow the same sort of concept. Think about the concept of doing it for your assignment as well. I will come back here, go to the edit, and I will change the zig to the zigzag. Or if you want, because I don't want to remove it, what I'm gonna do, I'm gonna copy the operation. I'm gonna copy it, and let's say I'm gonna paste it in here again. Let me do this one. Let me see whether I can paste inside. Okay, yeah, because there isn't any tool attached to it. Let me do this one. Copy and paste inside. Yes, this one, and then I can see whether I would be able to copy this one. Otherwise, I will create another one. Okay, so it doesn't let me. I just do the same thing I was doing it. I will do create an operation. Make sure it's this one, the same tool, the same workpiece, milling finish. Everything is the same thing. I will change this one to the 500, 0.08. Get the speed. Okay, generate. Sorry, make sure this one is a zigzag. By the way, the quick thing, if I click on generate, it shows me an error. Do you see that how a smart software? It tells me you don't have any phase geometry. So we'll make sure I will define this one, click OK, generate, good.
What's going on here?
Yeah, I will explain it now. Okay, so if you go there, now you can see the first one that I used. Let's rename it for demonstration. I will call this one zig, and I will rename this one to the zigzag. compare them together. The first one takes 4 minutes 5 seconds.
So we copying the. So what are we copying?
No, you don't need to do that one. You don't need to do that one. I will explain it in a second. This is
Okay.
something because I'm trying to explain, but no, for you it's
Okay.
simple. So you can see here, I have 4 minutes cutting and 14 seconds non-cutting. If I want to compare with the second one, which is the zigzag, I have 3 minutes 40 seconds cutting without any waste on non-cutting. Do you see how much I would be able to save this time with this really simple function? I just changed the method from the zig to the zigzag. The reason for it, because you can see the zigzag is doing the both directions, whereas the zig is just only one direction. That's one method of the doing the optimization for you. So this is one of the methods. This is today I just want to touch only on one of the methods of doing it, and that's this one. So in order to do it yourself, you don't need to copy it. I just wanted to copy it for you so you can visualize it better, but you don't have to do it. So in your case, what you need to do, you need to go there, the one you have. Let me get rid of these because I don't want to confuse you. So in your case, you see something like that, right? This is the exact same thing you're seeing it on your machine. Just right click on there, go to edit, make sure you change the zig to zigzag. That's it. And then you don't need to change anything else. Make sure you click on generate. If you want, you can verify it as well. You don't have to, but if you want, you would be able to verify it as well. And click OK and OK. So if you come back to the timing, you can see the time has been updated because you're using the different method of doing it. So that's one method of the optimization. And also that method of one way of doing the edit. So whenever you can come back to here to edit and change this one to zig, for instance. And you would be able to, even if I verified, you would be able to see what's the difference of doing that operation. You can see it's because it's the zigzag, it's a 2-directional cut. Great. So for the one that you're gonna check the recording, I'm gonna quickly say, once you finish everything, make sure you save it by clicking on the save, and make sure you save it where you have the file, the original file. Otherwise, whenever you move around that file, because this one is linked with that, you get the error. So make sure you save it because you're gonna use this file next session. So make sure everything is saved. It takes a little bit of time to do it. And so that's it for that. Hope you learned something new. Hope it actually was something useful. Thank you so much again for the one that commented back. Thank you so much, Van, Jeff, Tom, Hossein. Thank you so much for comments, as well as the Ovek and Charlie. Thank you so much. And please keep in touch with me if you have any questions. And so we'll continue next week with doing the operation in these 2 pockets. So next week we'll consider how we'll be able to do these 2 pockets and what method is suitable, how we would be able to optimize it. And then the week after, we go through these, creating the holes, and we're going to use the AI part of it to see how the software think that I should do that. I'll do it operation for us without I do every single of these stages that I've done for you. So we can see how smart is the software and compare it together, which one is better. Great. Thank you so much for attending the session. Take care, stay safe, and have a nice weekend. Thank you.